Hello everybody, getting ready to do lesson 6.5, Algebra 1 Math, solving special types of linear systems. And if you want part 2, part 3 of the PowerPoint/video, email me here for that, as well as the worksheet, class worksheets, online tutoring, solution PowerPoints for the skill checks. Those are all good. 6.5, solving special types of linears. So this is part 1 of this. Then we got a 32-point skill sheet here, and we got 10 points here of note-taking. So take note of that. Teachers, here's today's bell work. It's another killer word problem. Give your students 5 minutes to solve that. Okay, welcome back. And then let x equals cost for one song, y equals cost for one album. Here is our setup here, and then we have another situation here for 3x plus 2y. We have two different situations here for two different prices, and so if we combine this with this, we'll get a solution for both. 7x equals 693, x equals 99 cents. So there is our solution for it. So how much does a website charge to download a song, an entire album? So, 7x to be 693, then we have x equals 99 cents for that. And then 5 times 99 would be $9.99 for a 5-song record. Website charges 99 cents to download a song and $9.99 to download an album. There would be your summary of that. Okay, solving special types of linear systems. You found solution of a linear system. You will identify the number of solutions of a system. So a linear system can have no solution or infinitely many solutions. A linear system has no solution when the graphs and the equations are parallel. A linear system with no solution is called an inconsistent system. A linear system has infinitely many solutions when the graphs of the equations are the same line. A linear system with infinitely many solutions have infinite many solutions. Okay, so an inconsistent system, students, in your own words, identify that. And then a consistent dependent system here, identify that. Okay, example 1, a linear system with no solution. Show that a linear system has no solution. Here we go, equation 1 and equation 2. How are we going to show that? Well, method 1 is graphing. So here's the graph of these two lines. They both have, it looks like, the same slope here, and our y-intercepts are different because of this number here, but they are parallel, so there is no solution to these lines. They will never intersect. Lines are parallel because they have the same slope but different y-intercepts. Parallel lines do not intersect, so the system has no solution. Elimination, subtract the equations. We're going to use an elimination method here. 0 equals 8, so we just negate the bottom one here. This is negative, negative, and negative, so we have 0 equals 8. That's variables are eliminated, and you are left with a false statement regardless of the values of x and y. This tells you the system has no solution, meaning the lines are parallel with it. Okay, we're going to go on our guided practice now. We have this system here. Students, this is yours. Pay attention up here so you can do yours. Class work. Tell whether the linear system has no or infinitely many solutions. Here are two equations. So now we're going to add. We're just going to add these up, and we get 0 equals 9. This is a false statement. Since the variables are eliminated, you are left with a false statement regardless of the values of x and y. This tells you that the system has no solution. Okay, example 2, a linear system has infinitely many solutions. Show that the linear system has infinitely solutions. So graphing, here's a graph here. So they're the same line. This is the same as this. This is the line here. Y equals, this is solved for y, then this isn't solved for y yet. The equations represent the same line, so any point on the line is solutions. Linear systems has infinitely many solutions. Yeah. So substitution, we go for substitution here. Write equation 1, then substitute 1/2 for x plus 2 for y. We're going to prove it this way, so we're going to put 1/2 x plus 2 for y, and then solve. -4 equals -4, simplify. The variables are eliminated. You are left with a statement that is true regardless of the values x and y. This tells you the system has infinitely many solutions. It's the same line. Okay. So now we have a guided practice here with this bunch. Students, this is yours. Okay, our guided practice, no solution, infinitely many. So we have y equals this. So now we can just plug in. We can plug this in for here into this y here. Yeah. So we have -6x plus, and we multiply through. And we have 6x minus 12 plus 6x minus 12. And we end up with -12 equals negative. What do we do with that? The variables are eliminated. You're left with a statement that is true regardless of the values of x and y. This tells you that the system has infinitely many solutions. That is part 1 of 6.5. Part 2, part 3 available here. Thank you.